Hello and welcome to RAD-in-Action unit testing in Delphi. I'm Nick Hodges, a senior software engineer with Viva Systems, and today I'm going to be talking to you about just that, unit testing in Delphi. Here's the agenda for today. First, we're going to talk about what is unit testing. That'll involve as well some definitions. Talk about why you want to do unit testing, what the advantages are. Talk a little bit about how you do it. We'll look at unit testing tools and frameworks with Delphi. And then we'll have some coding examples showing you exactly how we do these techniques. So here's my goal today. I want to make you feel like this guy running down the street without your clothes on if you're not writing unit tests. Unit tests provide you an enormous amount of protection, comfort, and benefit. And if you're not doing them, I want you to feel like you're running down the street naked. So the first question you may have is, what is unit testing? Well, I'm going to tell you. Here's sort of the academic version of unit testing. That's the testing of code units in isolation to ensure that your code works. Please note that I'm not saying that your application works. I'm saying that your code works. Unit testing is the testing of code, not systems, not applications, not the integration of things together. Unit testing is also part of a larger testing effort. I want to make that clear. That unit testing is just one part of the different types of testing that you do, including integration testing, regression testing, acceptance testing, and all those other different kinds of testings. Unit testing is also something that proves that your code works properly. I mentioned earlier that unit testing tests your code and not your application. And so if you want to know that your code is working properly, you do unit testing. Unit testing can also act like bug repellent. Whenever you write a big suite of unit tests, those tests can quickly and easily reveal when a change results in a bug. A complete and thorough suite of unit tests will also help to ensure that any bug that creeps into your code will be revealed immediately. When you make a change and a bug is introduced, the unit tests can reveal them right away. Of course, finding bugs early makes them easier to fix. Unit testing will also find existing bugs in your current code. If you have a suite of code that you haven't written unit tests for, you can write unit tests for that code, and those unit tests will help reveal bugs in that code library. Proper and complete unit testing will also explore the edges of your code to make sure that it works in all circumstances. For instance, you might want to check to make sure that your integer math works at the very edges and boundaries of the integer numbers themselves. You might want to test the edges of a rectangle class, seeing whether the class performs properly when a point is just inside the edge of the rectangle or actually on the edge of the rectangle itself. The edges of your code are the places where errors are most likely to occur or can occur, and you want to make sure that your unit test coverage deals with those situations. This is an interesting side benefit of unit testing. Unit testing can document the proper use of a class. Oftentimes I'll be looking at a open source project. The first thing I'll do is go to the unit tests, because the unit tests will often show you exactly how the code should be used and called. So when you write unit tests, it's like writing documentation for your class. This is probably the most controversial thing I'll say about unit testing, because this is the most contentious amongst the developer community and management, and that is that unit testing saves time. Many developers believe that writing unit tests takes more time than it saves, but I don't believe this, and in fact I'm going to argue the opposite here. Writing unit tests helps ensure that your code is working as designed right from the start. Unit tests define what your code is supposed to do and immediately ensure that your code does it. Every unit test you write becomes a regression test, ensuring that down the line all of your code will continue to work and that it won't break when changes are made. All of these benefits save time in the long run, enabling you to move forward with changes and additions to your code with confidence, because you know that your code is working correctly at all times. You already test your code as you're writing it. You might write a simple console app. You might compile it and see it running. You're always testing your code. You might as well take that time and write good unit tests, because they'll have downstream benefits for years to come. Having a full, complete, and thorough set of tests that cover the complete functionality of your code might be difficult to achieve, but having it will give you peace of mind. You can run those tests anytime you want and know that your code is working correctly. You can make changes, do refactorings, and know that your code is still working properly. Knowing that, despite what you might do to your code, gives you peace of mind. All code changes and ages, but legacy code only occurs when code does not have unit tests. And in order to keep your code from becoming legacy code, write unit tests for it, and you can have the peace of mind that that code will continue to work no matter what changes are made to it. This benefit of unit testing is probably the hardest one for people to see and understand. It's one of those things that you learn as you go along, but unit testing causes you to design your code properly. It's a very happy coincidence that testable code is also well-designed code. If you write your code to be testable, you'll write it in an uncoupled fashion. You'll write it in a way that requires simple, smaller modules. You'll write it in a way that is well organized. Testable code, i.e. the code that can be unit tested, is well-designed code. And you'll find this as you go along. The more tests you write for your code, the better designed your code will be. Okay, so we've been talking about unit testing and sort of what its benefits are and why you should do it. But let's look a little more deeply at some of the definitions that are involved. The most obvious question to ask at this point is, what is a unit? Well, a unit is the lowest level of code that can be tested in isolation. And normally, this is a single class method. We'll use this definition, that is that of a single class method, throughout our demonstrations and the conversations that we'll have today. In addition, we'll be discussing what it means to test a class method in isolation. A little later, we'll be talking about isolation frameworks, or more commonly mocking frameworks. And so we're going to need to know what a fake is. Well, a fake is any class that provides functionality sufficient to pretend that it is a dependency needed by the class under test. There are two kinds of fakes here we're going to talk about: stubs and mocks. A fake is what you use in order to test your class in isolation. You don't want to do unit testing based upon something like a database. So you use a fake to pretend that the database is there, and those fakes can enable you to write your unit tests without depending on the actual database itself. A stub is a specific kind of fake that has no effect on the passing or failing of the test at all, and all it does is exist purely so that you can actually run your code. If your code requires a logging tool and you don't really care about testing the logging while you're testing the main functionality of your specific method, you can pass in a stub for the logging tool, and the logging tool will do nothing. That stub will do nothing, but it enables you to run your code because your code requires that logger. While you often hear the term mock used in the general sense, a mock is actually a specific type of fake. Mocks are a little more complex than stubs in that they actually determine the outcome of a given test. You pass a mock into the class that you're testing, and when a test is called, the mock checks the behavior of the class under test and determines if the class behaved correctly. If the class behaves correctly, the mock says, yes, the test passed. If the class behaves incorrectly, then the mock will fail the test. So a mock is a fake that can actually fail a test. And we'll see a little bit more about how these mocks and stubs work in the code demo. Next up is the question, what is test-driven development, or TDD? You see that a lot. It's a common term that's bandied about, and I don't mean this to be a treatise on test-driven development. You can decide whether you want to write your tests first or during or after you write your code. That's all fine and good. I'll just go real quickly through what test-driven development is. Basically, it's the notion that you write your tests first. You write a test, you run it and it fails, you write code, and you watch it pass until it passes, and then you write some more code and you watch it pass. And so this little loop takes place down here. And then once you get done, feeling confident that that particular test has been coded to its maximum capability, you start back up at the beginning and you write another test, watch it fail, write some code, repeat this loop here until you're ready to write another test. And the idea then is that the test drives your code. I'll actually show a quick demo of this in the code portion, but the notion is that your code is a result of the tests, and that's how the notion of decoupled testable code comes about. If you write tests first, you can't help but write testable code, and as I said earlier, if you write testable code, you're writing well-designed code. So there's a quick look at some definitions and terms that we'll use throughout the presentation today. The next question that probably comes to mind is, am I actually doing unit testing? And this is another topic that is commonly discussed. I mentioned this earlier, and I'll talk a little bit about it coming up. But you're doing unit testing if you're testing your classes in isolation. If your test requires any external entity other than an isolation framework, then you are doing integration testing. Now, I don't mean to denigrate integration testing. You should do integration testing. But before you do integration testing, you want to do unit testing. You want to test each class in isolation apart from any dependency that it has in order to make sure your code works correctly. And from there, you can go on and do integration testing, regression testing, acceptance testing, whatever kind of testing you want to do. But the trick to doing unit testing is to test your classes in complete isolation. In other words, you should be able to take your unit test executable, put it onto your grandmother's computer that has no notion of Delphi or runtimes or anything at all on it, and run that executable and have all of your tests pass. That is running your tests in isolation. Okay, let's dig a little deeper into this notion of testing in isolation. So here's a quick graphic that just shows your test driver or your test framework, which provides some stimulus to the class under test, i.e. it pokes it, it runs it, it does something to it. And then that class under test is checked. You use your checks or asserts to see if the results are as you wish them to be. And that's just the basic notion of a test. However, part of the problem you run into with this test is the idea that your class can oftentimes have secondary effects. In other words, the class under test might need another class that then in turn requires an external database, a second class that then in turn does some type of CPU intensive process or talks to the file system, or another class can require another class that then in turn requires some external server on your system. Anything can happen on the back end of testing a given class. The trick to testing your class in isolation, making your test testable, in fact, is to write your classes with the notion of this seam. And as you can see here, there's a notion that your class is separated from all of its dependencies very cleanly and very easily. Once you do that, you can then either note that the dependent classes are friendly classes that don't cause any harm. There you can put in a stub class or a mock class in place of classes that might cause external dependencies on other servers, such as a database or a file system or something along those lines. In this way, you can isolate your class using an isolation framework, i.e. the stubs and mocks that pretend to be the dependencies that your class have. And as long as you're writing your code in such a way that you can stub and mock out all your dependencies, then you are testing in isolation, you're writing testable code, and you're writing well-designed code. Okay, so we've talked about what unit testing is, what unit testing is not, why you want to do it, all those fun things. So now it's time to actually get down to the nitty-gritty and talk a little bit about how to write good tests. So here are some tips for writing good unit tests. First, only write one check or assertion per test. This is kind of controversial again as well, because oftentimes people do a lot of setup work and they want to run more than one check or assert in any given test. But I encourage you to resist that temptation. I encourage you to use the setup and teardown features to do your setup and teardowns, and allow only one check or assert per test inside of each individual unit test. Secondly, you should use the AAA principle, the AAA principle, which is arrange, act, and assert. So the first thing you need to do in any given test is arrange things so that the test can be run. Set your expectation, expected results, your expectation for the result. Act is actually call the method itself in order to run the test. And then the third thing you do is assert. That is, check to make sure that the result is what is expected. Here's another good tip. Don't put logic in your tests. If you're using an if statement, for instance, or some type of case statement, then you're running more than one test inside any individual test. If you feel the need to have logic or if statements inside of your tests, then you need to rethink how you're doing things. Your unit tests should be easy to run. You should be able to run them at the command line very quickly. You should be able to run them using the GUI test runner and see your nice green bar running across this from left to right. If tests are easy to run, you'll run them frequently. If you run them frequently, you will find bugs almost immediately. You'll see problems very quickly and you'll be able to fix them right away, knowing what recent changes you made. Write down the middle tests first. That is, write the tests that are sort of sweet spot in your tests. If you're doing addition and subtraction in a math unit or something, you might want to make sure that 2 plus 2 equals 4. That's sort of a down the middle of the plate test. Do those first, and then follow those up with tests at the edges, as we discussed before. Start testing things around 0. Start testing things around max int. Start testing things at the edges of what your class does, the extreme cases. Follow that as testing across boundaries. If you're doing addition and subtraction, as we'll do in our demo, we're going to test to see what happens if you add a positive number and a negative number together and make sure that that works correctly in our algorithm. If you can, test the entire spectrum of your class. Test everything that it can do. If your class has a enumerated type, write tests that check to see what happens when every value of that enumerated type is used. Sort of along those lines, try and cover every code path. If your code has an if statement in it, make sure you test both sides of the if statement. You can use a code coverage tool, run that against your unit testing executable, and it'll tell you what code paths in your class are not currently being used. Delphi has a good code coverage tool. Use it. Write tests that reveal a bug and then fix it. This is a very excellent technique. If you find a bug in your code outside of your unit tests, write a unit test that fails because of that bug. You can then quickly and easily debug that test, fix the bug, and then you'll know when the bug is fixed because your test passes, and now you have a regression test for later to make sure that bug never comes back. All tests should be independent of each other. You should never have to run tests in specific order. If you do have to run your tests in a specific order, you're not doing your setup and teardown properly, and we'll see how that works in the coding portion of the presentation today. All tests should be independent and able to run individually without any dependencies on other tests or anything at all. If you're going to raise exceptions in your code, test that. Create a situation in your arrangement, in your arrange portion of AAA, whereby the exception will be raised by your code, and ensure that it is indeed raised under the circumstances for which it is supposed to be raised. As I mentioned earlier, tests should never depend on each other. They should always be independent, and they should never rely on anything other than themselves. Again, that just gets back to the test in isolation. Use good names for your tests. Don't be shy about naming them. Don't be shy about having a nice long name such as divide by 0 raises an exception. Have that be the name of your test. Good names for your tests help you find and understand what happens when a test fails. If you just name your test test division, that could be anything, but if you name your test customer must have proper customer ID number, then you know exactly what's going on when the test fails, and you get a report from the test harness. It tells you exactly what test failed. It tells you exactly what the problem is, and you're well ahead of the game for fixing things. Run your tests constantly. Since they're easy to run, you should run them frequently. You should run them after every time you change code, really. They should be easy to run, easy to check the results of, and you should run them all the time in order to ensure that they're all always passing. Never allow your code base to get far away from passing tests. Run them as part of your automated build. Surely you guys are doing automated builds, and you should be. Run your tests and if your tests don't all pass, then the build is broken. That should be part of your automation continuous integration process from the very beginning. Bottom line on all of this, if it's hard to write tests, then you're doing it wrong. If writing tests is difficult, then you've written your code in such a way as to not be testable, and if your code is not testable, it's not designed well. I realize that there's a lot of existing legacy code out there that's hard to test, but if you're writing new code and you are not writing unit tests in an easy, straightforward manner, then you need to rethink how you're writing your code so that you can write testable and thus well-designed code. Okay, so we've talked a lot about theory so far. Let's talk a little bit about the specific tools and frameworks that you can use to unit test in Delphi. First up is DUnit. DUnit's been around for many years. First written by Juan Carlos Añez back in the 90s with the help from Kent Beck himself. And it is a venerable tool integrated right into the IDE, and it enables you to write unit tests, execute them either at the command line or using a graphical user interface with the green bar that everybody loves to see. We'll demo DUnit in the coding portion of the presentation coming up soon. DUnit is an open source project available on SourceForge, but it has languished as of late and has not been updated in some time. There are some projects that expand upon it, but the actual project itself has not been updated in quite a while. However, it is a perfectly serviceable and usable unit testing framework, and if that's the one you choose to use, I think you made a wise choice. More recently, there has been a project called DUnitX from Vincent Perret of Final Builder fame. This uses the new runtime type information inside of Delphi since Delphi 2010, and it relies on attributes to tag specific classes and methods as test fixtures and tests themselves. This is the unit testing framework that I'm using going forward, and it's the one I recommend that you do use. It's still a work in progress. There is not a GUI test runner just yet, but that's in progress and in work, and this is the more modern way of doing unit testing with attributes. We talked about isolation frameworks a little bit with mocks and stubs, but I'll give a formal definition here. An isolation framework is a collection of code that enables the easy creation of fakes. An isolation framework, more commonly called mocking framework, but mocking, of course, as we've seen, is only part of the story, is one that allows you to test your code in isolation. It allows you to create fake dependencies to isolate your classes so that they can be tested independently. Currently, the most popular Delphi isolation framework is called DelphiMocks. It's available on GitHub, again from Vince Perret and the folks at the Final Builder, and we'll see it in use in the coding demonstration coming up soon. There is, in addition, an isolation framework built into the D# repository on Bitbucket, built by Stefan Glenke. If you're interested in some of the things that go on there, you can take a look at that. We will be demonstrating, however, the DelphiMocks framework in the coding portion. So here's my final advice before we head off to look at code, and that is, first, only test the code that you want to work properly. If you want your code to work properly, test it. And then don't test the code that you don't want to work correctly and cause all kinds of problems down the road. If you got some code that you don't care about, that you don't care if you have to maintain it, you don't care about causing problems and all that kind of stuff down the road, having it quickly become legacy code, unfixable, unmaintainable, then don't test it. Don't bother writing unit tests for it. Okay, from here we're going to move into the code demo portion of the presentation, illustrating some of the points that we've discussed so far. So the first thing we're going to do is run through a very basic test-driven development scenario to give you the feel of how test-driven development works and how, in this project, DUnit works. So here I have an empty basic console application to which I'm going to add a new unit. I'll save that unit. I'm then going to create a very simple class called tCalculator. And to it I'm going to add a single function called add. It's going to take two integers and it will return an integer. And I'll use Control-Shift-C to create a stub for it there. At this point, we don't want to do anything. We want to write a test first before we begin. So I'll save this. I'll then go to the project group and I'll say File, New, Other. I'll go down to the unit tests and I'll create a new test project based upon Unit 7, or Project 7. And then I'll create inside of that a test case, and you'll notice that the IDE is smart enough to build for me unit based on tCalculator with add as its method, and it creates this automatically for me. And you'll notice that it creates completely the new test case. I'm going to save the whole project. It creates a new test tCalculator class, descends from tTestCase, which is the base class for all test cases in DUnit, and it has a setup project, and it has a setup method and a teardown method that are used each time a test is run. It calls setup and it calls teardown. That setup and teardown, of course, are going to create and free, we don't need to nil it, the calculator. Then it creates a test add method, which takes the two parameters that we need to pass, or gives you two parameters that we need to pass, and this calls the actual method itself. So actually what we want to do is a little housekeeping here. First, of course, using our AAA, we want to arrange, act, and then assert. That's what we'll do here in a minute. Well, let's do it now while we're here. Arrange is x gets 2, y gets 2. So we arrange things. We set an expected value of 4, and we'll use a refactoring to declare that for us. And then we want to act. That is, we want the return value to be whatever the method under test returns. And then we want to assert. We want to check true that expected value. I'm sorry. Let's use check equals, because we don't want to return false when we actually want to see what the actual values are. So we'll pass in expected value and return value, like so. Now we have a test. However, this isn't a very well named test. This is something that tests adding 2 and 2. So we will use the rename refactoring to call test adding 2 and 2. That should tell us exactly what that test is doing, and then when it comes time to debug the test or find the test runner will tell us exactly what the test's name is, and we know that what that test is doing. So now we can run this. We'll get a GUI debugger, and you can see the test fails, of course, because we have no code. Okay, so now we have a failing test, and let's write the absolute minimum amount of code necessary to make that test pass. That's the first step in test-driven development, right? The absolute minimum amount of code necessary to make your test pass. And that would be that. So here we go. I wrote that code. We run our test. Yay! Test passes. That's great. Okay, so we've got a test written, runs, and it passes. So let's iterate again. Let's write another test and see what happens. Looks like I forgot to press the button on that refactoring. So let's do it again. Just declick that and just run the refactoring. Okay, so now let's add another test to refine our algorithm a little bit. See what we do. Test adding negative and positive numbers. So let's do a little, test across boundaries. And I'm going to commit a cardinal sin. I'm going to copy this code just for the sake of expediency here, and I'm going to change this to, say, a 5 and a -1. So we're going to add a positive number and a negative number, and we should get the result of 4. Only I'm going to make this -2 just for fun, and we should expect a different result of 3. So now we should be able to run this, and we should see our tests. One passes, and one fails. Expected 3, but actually was 4. Well, that makes sense, because if we go back to our addition algorithm, we find that it's a little simplistic. Bear with me here. This is just a demo. It's a little simplistic. So let's fix that so that our test passes. I'm going to use this algorithm that my math buddy taught me. I'm going to use the absolute value of x plus y as my algorithm. That way I'll be absolutely sure that it's right. So, yay, now we're done. Now we'll run it again. And now we see, hey, our tests pass. So what do? We write another test. Let's write another test that tests the boundaries. What happens if I write a test called test adding 2 negative numbers? Oops, I guess I should implement that. And once again, I'm going to copy this code just to save time. I'm going to add two negative numbers, -2 and -4. That should equal -6. So let's see how we can do there. I will run it, run the tests, and that last one fails. I'm expecting -6, but it was 6. Well, now I can go back and refine my algorithm a little bit again. How about x plus y? Actually, so I just had a math buddy of mine. I'm going to go and get a PhD in mathematics to tell me that the algorithm should be x plus y minus 6 plus 3 plus 3, like so. Okay? And now I've done that. Now I'll run my tests, and all my tests pass. That's really awesome. So now I've got this ready to go. I've written some good tests that kind of test the boundaries and edges and that kind of thing. You can imagine some other tests that you might want to write that would do that. But I'm good. My tests are passed. I've got the basic down the middle test. I've got some edge tests. They all pass. Now here's the fun part, right? Let's put this into production, and you notice some inefficiencies. You notice that your math is not running, the addition thing is not running quite as fast as you think it should. And you go and you examine it, and you realize that this algorithm here is not really all that really good. I mean, there's that -6 plus 3 plus 3 part there, and you're like, why am I doing that? So the PhD told me to do it, but gosh, I don't know. Why am I doing that? And you want to refactor your code. You want to change your algorithm. Well, you can. I can now go in and just change my algorithm quite radically, actually. That's a radical. Think of that as a radical change to your algorithm, to your code that you want, the results that you want. Well, you've got a suite of tests. So you can save that. You can run your tests, and you've refactored your code, and you see that your tests all pass. And now you have confidence that your changes, your refactorings, have worked correctly because your tests all still pass. That's test-driven development in a nutshell. Okay, so we used DUnit for this project, or testing this project. What would the tests look like, and how would this project look if we were to use DUnitX? Well, let's take a quick look at that. We can create a test project for project 7 here by going to the IDE, and DUnitX ships with a small, simple expert that creates a DUnitX project for you. So let's do that. Let's double click on that. We want to add it to the existing project group. We want to create a test unit. We want to create setup and teardown methods just for because we need them. And we're going to call it TMyTestObject. I want to use I want to go ahead and add in Unit 6 to this project because Unit 6 is our calculator. And inside of Unit 7, which I'm going to save, I'm going to use Unit 6 inside Unit 7 so that we can see it. So what we have here now is a simple class that descends directly from TObject, but that has attributes attached to it. The first one here is test fixture. This attribute defines and declares the TMyTestObject class as a test fixture, a harness, a class that contains tests. And you'll notice that there's a procedure called setup and a procedure called teardown. They are tagged with the setup and teardown attributes as well, meaning that is the setup and teardown procedures. The setup will be called every time a test is run, before every time a test is run, and the teardown will be called every time after a test is run. So we need to declare a private variable called fcalc of type T calculator, and in the setup we will create an instance. Fcalc gets T calculator.create, and in the teardown we'll free it. Now, in order to add a test to this very simple class, all we need to do is declare a attribute called test, and we can go procedure 2 plus 2, or we'll call it adding 2 plus 2, excuse me. Test adding 2 plus 2, just like we did before. And we'll create the test. Now here, instead of using the check methods, we use a class called assert. And assert are equal, and we'll expect that the answer is 4, and we'll test fcalc 2 comma 2 as a result. This is just throwing in this real simple test fcalc.add like so, and that'll run the test. And you'll see the DUnitX doesn't have a GUI runner yet. It does have a nice pretty console output though, and you can see that the test passed. It's nice and green, and that one test passed. So that's how you use DUnitX. Instead of descending from a specific test class, test case class, as you do with DUnit, we declare attributes that define the tests and the setup and the teardown. And there's actually more attributes. There's a fixture level setup and teardown that gets called once each time for each fixture, and as well as some others that are being added. DUnitX, as I said before, is still a project in work, but it's very cool and it's very easy to set up classes using DUnitX as test fixtures. You simply declare the attribute, tag any methods you want in your class with the attributes that you want them to have, and they become tests quite quickly. It's very, very easy, very, very simple to use, and it's very powerful. So I'm going to press forward with DUnitX. So let's take a little closer look at it. For instance, let's take a look at the source code for the project. You'll notice that it includes the single class that you do need for DUnitX in the code that you write, that is DUnitX.testFramework. It also includes the test runner, which contains the class that creates the runner. It contains a NUnit output as well as a console and a logger console. In order to have a project that uses DUnitX, you need to create a runner, have it use RTTI, that signals to it to use the new RTTI. We're going to use a console logger as the logger, and we're going to use a DUnitX file logger as well by default. We're going to add the two loggers to the runner, and then the runner just executes. And in this case, we're going to write out to the console as long as we're not using continuous integration. That's what the project looks like. Here's a quick look too at the assert class. You'll notice that it is a class with nothing but class procedures attached to it, and a large number of overloaded methods that allow you to write almost any kind of test that you want. You can test that things are equal, that they're not equal, that they're two objects are the same. You can test if things are null, they're not null, test if things are empty, not empty. And in a minute we'll take a look more closely at will raise. But the assert class is pretty thorough, pretty complete, and you could certainly create a descendant class that would add to it if you wished. But it's a pretty complete set of test assertions that you can make in order to write your tests. Okay, so I talked about how one of the things you should test is you should always test how your class raises exceptions, and that it does in fact raise exceptions when it's expected to. So let's create a new console application here. I'm going to add a unit to it just like before. And in that unit I'm going to create a simple class, just another class that we'll use for testing. T exception raiser is a class, and we're going to have a procedure called raise exception if for, and it'll take a simple integer as a parameter, and it will do one thing only. If a integer equals 4, then raise oh no, a integer was 4. And that's really bad. Can't do that. If we want to use exceptions, we need to, of course, add to our uses clause system.sysutils, like so. Save this out, and this should run just fine. Okay, it does compile and run, doesn't do anything. So I'm going to go ahead and create a new DUnitX project. Add it to the existing project group, create a test unit. I don't need setup, or I do need setup and tear down methods, like so. I'm going to use or add unit 8 to unit project 10. I'm going to use unit 8 and unit 9. And I'm going to declare a private variable, just like before. F exception raiser, T exception raiser, and we'll create an instance every time a test is run. And we will free it every time the test ends. And now we're going to go ahead and test that exception is raised, like so. And here is how in DUnit you test to see if an exception is raised. You assert that the code we're going to create will raise a specific given exception. So in this case, what we need to pass here is a simple procedure, an anonymous method that is a procedure that in fact calls our code. Raise exception if it's 4, and in fact we want to the exception class that we expect is exception. If we want to declare that class, we need it in our uses clause, like so. And we need an end at the end of our exception method. Let's make sure it compiles. Save the new unit. Make sure it compiles, which it does. And we'll run it. And we'll notice that we haven't written any tests yet, because I forgot to put the attribute on the method for our test, which we will now do. I'm going to save everything. I'm going to run it, and look, our test passed. And if we put it in the debugger, you'll notice that when the test runs, it does indeed raise that exception. Oh no, the integer was 4. But the test passes because this will raise method expects that an exception will be raised of type exception, and it traps it, captures it, and causes the test to pass. Now, of course, the opposite is true. We want to make sure that that thing isn't raised when it shouldn't be. So we'll create test that exception is not raised, and we will basically call this same code. I'll do the commit the cardinal sin of pasting in the interest of expediency, and I will now call will not raise. Get rid of this. Oops. Run it again, and you see now I have 2 tests passing. So that's how you handle exceptions in DUnitX. You simply pass in a anonymous method that calls code that you expect to have raise an exception. You tell them what kind of exception it expects to raise, and of course in this case it raises any kind of exception, but you could create your own exceptions, pass in specific exceptions, it doesn't matter. In this case it will not raise the exception, in this case it will raise the exception. The assert class will take care of handling and passing your tests based upon the execution of an anonymous method. Now if you want to use DUnit, let's create a new test case for DUnit. Let's create a new test project. Call it that. Save it. We'll drag and unit 8 in to it. Unit 8, if I'm not mistaken, is our class, yes. And then we will then create a new test case using unit 8 and the raise exception if for method. And in this case, for DUnit, it's quite simple. You just simply set the expected exception variable to be an exception class that you expect will get executed in the call to raise exception if for, and again we need to have sysutils in our unit. And now if we run this, whoops, now if we save everything and run it, we should see that again this test passes. Oh, I didn't set a integer to be 4. I'm sorry. Now, once again, if we run it, we run the test, it does indeed raise the expected exception, and DUnit is pleased. All right, so let's take a look at a set of tests that are a bit more robust than what we've had before. This is a set of tests for my HTML writer open source project. This is a project that creates HTML based upon your code. And I have written for it a large number of unit tests, testing each and every method on HTML writer, ensuring that each one adds exactly the correct amount of HTML just as it's supposed to do. You can see these run if you like. They all run, they all pass. And what this enables me to do is to savagely refactor HTML writer. If I decide that the current algorithm or the current way that I'm building the string of HTML is not the way that I want it done, I can change it knowing that as long as my tests pass, HTML writer will still function as designed. And that's the real strength of unit testing, is that it ensures that your code works as it's designed to work and that it continues to work as it's designed to work as you make changes, bug fixes, and whatnot. A failing test would immediately show you that a change you made has broken something, and all the passing tests immediately show you that the change you made works as designed. And that's the whole goal, right? Is to keep your code doing what it's supposed to be doing. Okay, so far the tests that we've looked at have been pretty simple, and the classes that we've been testing have been simple as well without any real dependencies. And certainly I talked a lot about testing your code in isolation earlier during the slides. And so I want to show you now just a little bit about DelphiMocks and how an isolation framework can be used to mock up or stub out, either one, dependencies in your code, enabling you to test your classes in isolation. So I have a set of demo applications that I'm going to use that will demonstrate the DelphiMocks framework. The first one here is a simple stub demo called Simple Stub Demo, and it basically has in it two classes, a class and an interface. The iLogger interface we'll call log on a string, and you can log that anywhere. You can implement the interface however you like. In this case, it really doesn't matter. It could go to a database or a text file or something. Then we also have the class that we'll be testing and looking at, and that is the $to galleons converter. It takes an iLogger as a parameter on its constructor because it is dependent on an iLogger, and so good dependency injection techniques mean that you use constructor injection to pass into a class any dependencies that it has. It stores that dependency internally, and as you can see, it uses that logger whenever it does a conversion, as any good bank should do. It wants to log every conversion that it does. The real interesting part comes in the testing of this class. We're going to use the DUnitX framework to test our converter, and we're going to use the DelphiMocks framework to both stub out and mock the iLogger interface. And as you can see, Mocks framework provides the ability to stub out the iLogger. You pass it in as a generic parameter, a parameterized type to tstub, which is in fact a record, and now I can create an instance of logger that is a stub of iLogger. In other words, it just implements the interface but doesn't do anything else at all. That allows us to then create an instance of $T to gallons converter, passing in the stub. We can then check the values of the result of the call to convert dollars to gallons, allowing us to check to make sure that the conversion is done properly. And we can run our assertion and then free our converter, and I'll be on our way. And here's a perfect example of a stub, right? We don't care about the logging. We don't want the logger to do anything, but we have to provide a logger. So we provide a stub logger that does nothing but allows us to create an instance of the class under test. Now that's an instance of using a stub to enable the class under test to be tested. But however, sometimes you want to make sure that the class itself is handling the dependency and doing something with the dependency while it's being tested. And you actually want the results of that dependency check, if you will, to determine whether the test passes or not. So what you use there is, as we discussed before, a mock. A mock, again, is a fake that can fail a test. So this time, instead of declaring it as a stub, we're going to declare temp logger as a mock for iLogger. And we're going to create it here. We're going to put in 2, and we're going to expect to get out 1. We're going to set the temp message to be converted dollars to gallons here using a formatter. And then we're going to do something curious here. We're going to take the temp logger, we're going to set it up, and we're going to expect that once when I call log, I'll use temp message. And you're going to expect that that happens somewhere down in the bowels of the dollar to gallons converter class. So temp converter, we create an instance of it. We call dollars to gallons. Oh, by the way, when we pass in temp logger when we create the instance of dollars to gallons. We then call the convert dollars to gallons method, and then we call verify on the logger. And this is really our assert. We've arranged, acted, and asserted. This is really our assert. Did the expectations get met? Did the thing that we expected actually happen? Did the log message get called with that message as expected? And the answer is yes, it did. Our tests passed. So that's a mock that determines whether or not a test passes based upon the behavior of the dependency inside the dollars to gallons converter. So that was a simple example illustrating the basic difference between a mock and a stub. Let's take a little deeper dive into the mock for our final demo. This is a demonstration of a credit card validator. There's an interface called iCreditCardValidator that determines whether the credit card is valid or not. Then we have an implementation of that interface here with the credit card validator. And then we have a credit card manager that takes that iCreditCardValidator as a dependency in its constructor, and the credit card manager can check to see if a card is valid, as well as process a credit card for a given amount. This is just a demo application here, of course. There's just a few things that we need to know. One is that a credit card will only be valid if it doesn't have a 7 in it. If there's a 7 in the credit card number, it's invalid. Again, just a simple way to invalidate a credit card for demo purposes. The real interesting part, again, comes with the tests. We're going to use the DUnitX test framework. We're going to have a test fixture here. We're going to ensure that the proper amount is returned when the card is good, and we're going to make sure that the charge returned is 0 when the credit card is bad. And this is just another example of using a mock. Here in the first test, we establish a good card value. There's no 7 in it, so the card is good. We're going to charge $49.95. We're going to expect to get $49.95 back when we do the charge, so we know that's what the charge was. And we're going to create a mock using the iCreditCardValidator interface. Now, once we have that mock, we're going to set it up such that it will return true when isCreditCardValid is called with the good card value. So when we call isCreditCardValid inside of the process credit card statement method that we have for the test, then we're going to ensure that that is the case, that it returns true. We're going to verify that fact, and then we're going to ensure that the expected result is equal to the actual result. And in the second test, we're going to do basically the same thing. We've got a bad card that has 7s in it. We're going to charge the same amount, but we're going to expect 0 because a bad card should return an amount charged of 0 and let you know that a bad card was returned. So again, we're going to return false when is credit card valid is called inside of the call to process credit card. So again, the mock is setting up an expectation that needs to be verified and validated when we make the call to the actual method that we're testing. So we can now run these tests, and you see that they both pass. And just for the sake of argument, if I change this to true, in other words, if I say that it will return true when a bad card is sent through, that test should fail, and it does. So that's another quick look at the use of a mock to provide information about tests and about the dependencies inside of other calls to other tests. And that should be about it. We've covered the gamut of unit testing, and we've seen how you can do unit tests, test-driven development, a little bit about mocking and isolation frameworks, and this is how you can reach me. You can get the code seen in our demos today under the Coding in Delphi portion of nickhodges.com at Bitbucket. You can find me on Facebook, Google+, LinkedIn, all the usual hideouts. And now it's time for questions.
So here's a question here. It says, I missed the dependency injection topic like Spring 4D to make your code testable, or is that another webinar?
That is another webinar, yes. One which I'd be happy to do if you guys want. But yeah, dependency injection is covered well in my book, I think. And on my there's a number of articles on my blog as well about it. And go ahead.
I was going to say, and further, it says, can your unit tests depend on the dependency injection, or should they try to avoid that?
They can, but you should probably try and avoid that in that you should use mocks and other objects to fill in any dependencies that you do have.
Okay. So actually, while I'm looking for questions here, I'll give you one I have.
Okay.
So one thing I've found so in your demos, you copied and pasted code a lot. Is there a better way of dealing with repeated code than copying and pasting code, or?
I don't know about that. I mean, that was just for demo purposes. Your tests may end up being similar, and I guess you should just a disciplined developer would just type them out and not use copy or paste, because we all know that copying pasting code is evil. So I would just generally avoid that, I guess.
How do you mock out a T dataset? There is no I dataset standard in Delphi.
Probably that would be a good example of maybe writing your own T mock dataset. Probably don't want to tie your code too tightly to a T dataset, but you don't need to. You don't need to pass in you don't. Well, let me see. You don't. Yeah, you'd have to write your own mock at that point. Would be the only way to go.
So how do you isolate from, let's say you're unit testing your own network communication components, how do you isolate that from the network connectivity?
Through mock classes, you create classes that send back canned responses to specific inputs, and that way you can pretend that you're talking to a network and not really talk to a network.
Can the tmock and tstub structures be used with DUnit also, or are they only DUnitX?
No, they can be used with DUnit and DUnitX, yeah, for sure.
Is it possible to check exceptions also by value, e.g. message or error code, and not only by class?
I believe so. That's an interesting error code. You certainly could if there's an error code returned. I mean, you could check the value of the error code and see that that is done. But the messaging, I seem to recall something in the assert asking about comparing messages, but I'm not sure. I confess I'm not sure.
How would you implement GUI testing in Delphi?
You probably wouldn't use Delphi to test your GUI. You'd probably use a third-party tool like Test Complete or some other GUI testing tool. I always liken it testing to a pyramid where at the bottom of the pyramid the most tests you write are unit tests, and then the second tier is integration tests, and you write fewer of those, and then at the top of the pyramid is GUI testing where you write very, very few GUI tests. My personal view is that GUI testing tools are very, very brittle and very, very difficult to use, with all due respect to the companies that make them, and that you should place most of your emphasis on testing your code and your integrations of your code, and try and make your GUI so thin that there's nothing left to test really after you've done unit testing and integration testing and other kinds of testing that test your code and integrations of your code.
Is there a good way to test if ANSI strings are equal in DUnit?
Yeah, it should check to see if they're equal just using the check equals call, or you can use compare text, or you can use the equal sign.
Does DUnitX support FMX in that can the tests be run on OS 10 and mobile targets?
I don't believe so right now. It's an open source project, and so those things can be built. There is no GUI runner just yet in DUnitX. When I say GUI runner, I mean the one that has the tree view and the little green bar going across the bottom. Although that's being worked on. If it were built in FMX, then they would run on OS X. I can't imagine trying to run your unit tests on the mobile target itself. Trying to run your unit tests on an Android device, but theoretically that would be possible.
It would seem like, since if you're using it for actual unit testing, then you could just set a Windows target and run it there because you're testing the functionality.
Right.
And if it becomes dependent on the platform you're running on, then it becomes integration testing.
Correct. Well said.
Is there a ETA for GUI runner on DUnitX?
I don't know. That again, it's an open source project, so it depends on the contributions of the people working on it. I know Robert Love has been making a lot of contributions to the project, and hopefully we'll see a GUI runner. I find I can get along without the GUI runner because the console application output's actually pretty complete, but I certainly would like to see a GUI runner on DUnitX, absolutely. Feel free to contribute, I should add.
So Robert Love is on the call here, and he said to avoid copy and paste, you can use data-driven test with the t-test case attribute in DUnitX.
Good point. I should have mentioned that. I didn't have time in the demo to demo that.
I know I read some of Robert Love's blog posts about DUnitX, and there's a lot of really cool stuff you can do with that. That's a really impressive framework.
It is. It's pretty cool, and it's made possible by the cool new language features in Delphi, like attributes in particular, and the runtime type information. It's actually not that complex to build, and it's cool. DUnitX is very, very cool.
So how would you suggest selling unit tests to my team? It says I work with very conservative developer environment, and so only use them myself in my private non-work projects. How can I sell their value? What is the key thing?
Well, I tried to cover that in the presentation. I guess the key thing is that they save you time. as I mentioned, people don't necessarily believe that, but it's absolutely true. And I guess the biggest sell point you could do is if you're doing it yourself, then be the best developer and write the best code, and it's no coincidence that your unit testing will the unit testing you're doing on your code will make your code the best code in the team, and you can show that and demonstrate that. Just be a living example of why unit testing works. I see the follow-up part there is how do I handle their worries about spending extra time to develop something because writing unit tests is useless time? Well, it's far, far, far from useless time. One of the points I made too, and I think it's an important one, is everybody tests their code. Everybody runs the code. They write it and then they run it. They write a little console application to run their code before they integrate it or whatever. Everybody's testing their code. It's just that unit testing is a permanent way to do it. It leaves you with a suite of regression tests that you can run continuously, and it saves time. I don't know how to, and I understand it's hard to convince somebody of that, but it does.
I heard once the analogy that you don't need to sell your team on your use of a case statement versus an if statement or vice versa. You just do
right.
it. You do what works, and when you, like you said, if you're the best, all of a sudden producing the best code, everybody's going to say, hey, what is it you're doing? Are you using if statements now or what? And you say, no, it's unit testing.
Yes.
Assume a large Delphi project, a vector editor that is not well object-oriented programming design. Is it better to implement unit testing continuously, do a full code rewrite at one time, or not to use unit testing for that kind of application at all?
Well, that's a difficult answer, or difficult question to answer, I should say. And I'm facing that exact situation in my work right now. We have a big project that is has a case of RAD-itis, I like to call it. Whereas there's a lot of on-click programming and huge methods that are all sort of tied integrally to the GUI and all that. And the approach I've taken is to try and find seams into the code and write interfaces where I can. For instance, one of the first things I did was I created, it's probably badly named, but I created a T query runner that would run all the queries, and I isolated the running of a query away from the actual code itself so that I could control how the query was run. The application I used was literally using raw ADO connectivity. It talked directly to the ADO library. So I created an interface that plugged into that. It's pretty leaky abstraction, but a leaky abstraction is better than no abstraction. And I started using FireDAC instead of raw ADO, and that enabled me to isolate it. So I guess the answer is you can start unit testing your code by isolating specific instances one byte at a time and writing interfaces for those instances and then testing the implementations of those interfaces.
So how do you deal with, with object-oriented programming, you have the idea of encapsulation.
Sure.
How do you deal with testing what would otherwise be a protected or private member of a class?
You shouldn't feel the need to do that. If you do, then that method probably ought to be public. If your method is private, then you probably are calling that somewhere in a public method, so you test that public method. Same with protected, right? That's the general rule. I would say that that's my answer. If you feel the need to test a protected or private method, then it's probably ought to be public.
Okay. So here's a question about using DUnitX with versions besides Delphi or XE5, and also will it work on Windows 8?
DUnitX will work on Windows 8 just fine. Yeah. I believe DUnitX is Delphi XE and above. It uses I'd have to check the web page. I don't know if I bring it up. I don't know exactly. I think it's DUnitX. I think it's Delphi XE and above. I could be wrong. I'm sorry.
So Robert Love chimed in here say
There
DUnitX
we
does
go.
support Mac OS 10, but not current mobile platforms. He
Yeah.
added the Mac OS 10 code a couple months ago. I remember in your book, I can't remember if it was DUnitX. I know XE and above will run DUnitX and DelphiMocks, but I can't remember if one of the. I think DUnitX might work with earlier versions, but maybe it was XE2, somewhere around there.
Yeah,
Mox.
Mox definitely I think needs XE3 and above.
XE3 and above. Okay.
Because
Well,
it
that might be
uses
what it is.
it uses T virtual interface, which is an XE3 and above. Yeah.
So on the DUnitX page, it says it's designed to work with Delphi 2010 and later.
Okay. Thank you, David.
Robert
That's
just
DUnitX, sorry.
chimed in with that as well.
And there were a couple questions out. Let me just chime in quickly. There were a couple of questions about database unit testing, and I put a link into the Q&A log. We had a session way back when in Data Rage, I think Data Rage 1 or Data Rage 2, by Giacomo, where he did a writing unit test for SQL databases using Delphi. So you'll find that link, and that's available for download from Code Central.
Well, actually, that reminds me. The last Code Rage, Jeff Lefebvre did a really good session on moving away from, as you put it, Nick, raditis, where you have all your code in your on-click event handlers.
Yeah.
And he showed how to refactor it into becoming more loosely coupled code, so that it wasn't specifically for unit testing, but that would definitely be something that you could use on that path.
And that was one of the points I made in the talk too, was that testable code is well-designed code, and well-designed code is testable code, and the two go hand in hand. I think I just used the phrase "happy coincidence." So yeah, I should look up that presentation. That sounds good.
How can you convert your DUnit tests to DUnitX?
There's a compatibility unit inside of DUnitX that uses check. You know, it writes. It's an adapter class around assert that uses the check calls that are native to DUnit. So it's fairly easy to use that to migrate your code forward. Basically, you would take your classes that are descendant of T test case and just add the test fixture attribute to them, and then take your protected methods that are actually tests and put the test attribute on them, change the uses clause, and you have a DUnitX compatible set of tests.
What tools can be used to measure code coverage in Delphi?
Delphi actually has a very excellent code coverage tool, and I think if you type Delphi code coverage into Google, you'll find it. Let me do that now.
On Google Code?
Yep, it's the first hit. It's on Google Code. It's called Delphi Code Coverage, and it's a very good tool. I wrote a blog post about it, so if you do the Delphi Code Coverage, I believe you'll find, yeah, my blog post is the third link down in my Google results.
So you said there should only be one assert per test. Why?
Because you want to isolate your tests just like you want to isolate your code. If you have more than one assert, then all the asserts don't necessarily get run when you run your test, because if you have 6 asserts in one test and the first test fails, then the other 6 tests don't run and you don't know the results. And it's also difficult and challenging to debug and find out which test in that of those 6 was the one that failed. So you want to isolate your tests in order to make it easy to find out which test failed.
I lost that one before I could type the answer. making tests can also be bug prone. How can one avoid writing erroneous tests that give properly operating code that actually is wrong, i.e. 2 + 2 = 5 shows okay?
I guess just be careful. You're right, all code will have bugs, and even your unit tests, I suppose, will have bugs. So I'm certainly not going to tell you to write unit tests for your unit tests, but
it would seem like that if your unit test fails, you could look at the unit test and see if it's wrong. But
sometimes that happens, yeah.
Your
sure.
unit test, your code tests your unit test, your unit test tests your code, really.
Yes. If your code is working properly and your test is wrong, the test will break, and then you'll recognize that the problem is in your test and not in your code. So the unit tests sort of test themselves is the way it works.
I read once that if you should make sure you don't use the same method or same implementation in your unit test as you do in your code. So if you shouldn't write the same logic to test your code that you wrote in the code.
Yes.
And so by having two different ways, even if the unit test is hard-coded or poorly, inefficient, because you're using a different mechanism, you're not likely to reproduce the same errors.
Correct. That's a good point.
It's a question about mixing production code and test code.
Should never do that.
Never do that. There's a lot of questions here, and I'm not sure if I'm going to get to all of them. I apologize to everybody. How can I test VCL components?
Not with unit tests. VCL components are graphical in nature. I assume you mean graphical, T graphic control descendants or T wing control descendants, or those would be tested with a GUI running tool or manually tested. You can't really use unit testing to test a graphical control.
But you can still test parts of the unit or parts of the VCL, right?
Sure, you could. Depends on what you call the VCL, I suppose. At some point, it's the runtime library.
Can I do unit tests on procedures and not classes?
Sure, you can. You don't need to necessarily test a class. You can just call string replace and write a unit test for string replace, no problem.
I read one a second ago that was really good, and I can't see it. How can I test a form?
A form you'd have to test again with something like test complete or some type of GUI runner tool. The goal of good clean code would be to make the code inside your form so loosely coupled to your actual business logic that you don't even really feel the need to test it. That because you're testing your business logic, the form is just such a thin layer over the top of your business code that you don't even feel the need to test it.
Oh, so the question was about using mocks. Does it require an interface, or can you do it without interfaces?
It requires an interface that descends from invocable. As a matter of fact, I should have mentioned that in the presentation, and I didn't. You can only mock interfaces, I believe. Somebody correct me if I'm wrong, but I believe that's the case.
Can you just show the tmock generic source on your screen?
That'd be up to you guys.
I don't have access to the screen right now, so
maybe there was a couple of questions too about how much of the mock use of mocks is covered in the book, Nick.
I have a whole chapter on it. In the interest of time, I wasn't able to cover as much as I wanted, but there's a whole chapter on mocking in the book.
So Morrow and others, if you need more get the book.
I've seen a couple of questions about using DUnitX with things like Jenkins and other continuous integration servers. Yes, you can do that. There is an NUnit runner that will output the NUnit XML that is agreeable to things like Jenkins and other continuous integration tools. So you can absolutely use DUnitX with a continuous integration tool today.
What do you think about the setup once and teardown once to only have to create a database connection once for a suite of tests?
Yeah, in DUnitX there's a setup fixture and teardown fixture attributes that you can put on methods of a class that run once for the entire suite of tests, as opposed to setup and teardown that run once for every individual test. So you can do it that way. Setup fixture and teardown fixture attributes.
Okay. Does DUnitX give the coverage of the tested unit, and I need to use the code coverage?
Yeah, DUnitX does not provide code coverage, but it would be cool if there was some way to integrate the code coverage into the unit testing. That would be a very cool feature. For instance, one of the things you can do is you can run the code coverage tool against your unit test executable, and it will show you if you've covered all your code paths with your tests, and if you haven't, then it pinpoints exactly the code paths that you need to add tests for. It's a very, very powerful technique.
It says refactoring the attributes of a procedure will cause a large amount of refactoring of already written tests. Any hints to keep that work as low as possible?
I don't necessarily agree with that notion. I mean, if you refactor your code and create new methods, then you should test those methods. So I guess there's no shortcut. There's no silver bullet or shortcut to writing tests. But if you create a new method and you write a test for it, you've got that integration test, you've got that regression test for as long as your code exists, and that's a good thing.
What's the difference between DUnit and DUnit 2?
I do not know. I've never looked at DUnit 2, I confess.
And your book's currently only available with people that buy or upgrade to XE5, and then it'll also be on CreateSpace?
It'll be on CreateSpace hopefully within a week. I've got the current status of it is I have the galley proof, the proof books that they send you, and I found some errors that I want to correct before I start selling the physical copy on CreateSpace. And then the electronic distribution is available with purchase of XE5 from Embarcadero, and that will run through this quarter, I believe.
Is it possible to configure the DUnitX in order to raise a warning when two test cases with the same input give the same result, like duplicate tests or tests not deep enough?
No, it doesn't do anything like that. But that's kind of an interesting idea. You could probably get it to do that. But
do we need an extra project for testing unit, or can we have it all in one project file?
You should most definitely have a separate and complete project for testing. Your test should definitely be completely separated from your actual production code. They should the executable for your test should be completely compilable and runnable separately from your production code. There should not be any tests in your production code at all.
What about legacy code, which would require a lot of refactoring? Should it get unit tested to some degree? Is it worth the effort?
Well, the purist would say yes, but of course that's a decision you have to make for yourself. Certainly, any new code you write should be unit tested. I would strongly encourage you to unit test any new code that you write. And as I tell my team, if it's hard to unit test, you're doing it wrong. If the code you're writing is hard to unit test, you're not writing it correctly. That's why you should do test-driven. You can do test-driven development to make your code testable, and then the happy coincidence occurs where your testable code is also well-designed, decoupled code.
Can you test concurrency like threads?
You can. I confess I don't have a lot of experience with that. That would be challenging to test. That's the best answer I can give at this point.
Is stubbing and mocking only possible in DUnitX, or does it also work with DUnit?
It works with the unit too.
Delphi code coverage has not seen updates in 1.5 years, and I experienced exceptions inside Delphi code coverage that prevented me from using it. Are there any alternatives?
I don't know of any alternatives. I don't have any trouble using it myself, but if you are, I believe the author of it is still out there. When I wrote my blog post, he commented on it. So even though it's been a year and a half, it's still, the author of it is still actually out there somewhere, so you might be able to get in touch with him.
If you separate production code and test code, then can you introduce errors by copying and pasting code?
Let me be clear. I don't think you should separate production code and test code. You should use the same unit in your production, the exact same unit in your production code and your test code. Maybe I was confusing on that point. The idea is you have a single unit that you use in two different projects. One project is your test project, and the other project is your production project. You use the same unit in both places, so you want to test the exact same unit. You want to test the exact same unit as you're using in your production code. You just don't want tests in your production project, and you don't want production stuff in your test project.
Speaking about command line, how does the tool report that the test failed or not? By exit code?
I believe so. From the command line, there's DUnit. Both DUnit and DUnitX have the XML output that is friendly to continuous integration. DUnitX has a graphical output on the command line that you can use as the one I showed and the one I used in the demos with the green and the red text. A console application is output in DUnit with a series of dots and it puts an F in there if a test fails. There's various ways to output it. For command line, if you're just visually checking the results with command line, it could be any number of different things. If you're wanting to use the command line runner in Jenkins or other continuous integration tools, then you can use the NUnit output that will be readable by the Jenkins server.
Am I missing the point if I think the dataset mock could internally contain a T-client dataset?
No, you could do it that way if you wanted to. That would be a good way to do it.
How can one be sure that enough test cases have been added?
You can't. You can always write more tests. You could probably always find another case that needs to be tested. A suite of unit tests should be ever expanding as time goes forward. I mentioned in the talk about how you should if you find a bug in code, then you should write a unit test that reveals the bug, debug the unit test, and fix the code so that your unit test runs. That's the way the database team on the Delphi R&D team did it when I was there. I don't know if they still do. I hope they do. Was that you couldn't even bring the developer a bug that didn't have a unit test with it. If you wanted to submit a bug to him, the QA department had to write a unit test that revealed the bug. That worked great because then you have a regression test. It's super easy to debug, and you isolate very easily and well. The QA department was able to isolate and debug or isolate the test very quickly using a unit test.
One of the questions that came up, I think you answered it, part of it about the Delphi code coverage open source project that hasn't been updated since, I guess it was 2012 maybe. SmartBear makes AQ time, which we have included a version. The Pro version has code coverage analysis used for Delphi, for C and C++, for .NET, Java, and other things. So if you need a code coverage analysis tool and you don't mind paying some money, check out SmartBear. I put the link in the Q&A log.
Good.
Search for AQ time code coverage analysis.
Thanks, David. That sounds great. I should have realized that. You're right.
I was thinking there was one that did that, but I couldn't remember which one it was. So thank you. Will DUnitX be integrated and shipped with Delphi in the future as well?
I'll leave that to you, Jim.
Yeah, maybe. That'd be great.
Well, Marco's here this week, and they're doing some meetings, so I'll bring that up with Marco Cantu, who's the Delphi product manager.
I know. Well, so my impression is that DUnitX, I mean, it's still in progress. I mean, it's still workable, but it sounds like there's might be a little bit more that needs to be done before it's completely ready for prime time. What's your impression, Nick?
Yeah, I think having the GUI runner really will be a big milestone. But I don't know if ready for prime time is the right phrase, but I agree that it's not completely polished. It still is a work in progress. It's very usable, and certainly you can use it in production. You can use it as a testing tool, moving while you write your code. But it has got some missing gaps in sort of the full featured functionality. I agree.
Yeah, I wasn't trying to say it wasn't a useful tool. It says, do you agree that because 80% or because of the 80-20 rule, which is 20% of the code runs 80% of the time, it is best to only test that 20% of the code?
I wouldn't say only test that 20% of the code. I would say that should be the place where you start, and that should be the place where you concentrate your efforts. But I would argue that you want to test 100% of your code. And that may be challenging, but it's not something you'll ever regret.
Well, especially as you add tests for bugs, right? I mean, you're going to get...
Go ahead. Sorry.
I was going to say, as you get bugs in that other code, you're going to eventually be adding tests there.
Well, that's like I said at the end. Only if you want the code to be buggy and will end up as legacy code, then don't test it. That's the bottom line.
So, is the Delphi code coverage tool non-dependent of unit testing framework, or is it only compatible with DUnitX?
It's completely in the code coverage. Delphi code coverage, the open source project, is completely independent of any particular framework.
Code coverage does not cover generics very well.
Okay.
Giovanni says.
That may be.
Okay, I think I'm getting caught up here. There was someone saying they definitely want to see coverage of the dependency injection webinar in the future. That would be great. Check out your book in the meantime. And
I did a dependency injection webinar at Code Rage a couple Code Rages back. That's on my YouTube channel. And my book certainly covers dependency injection very deeply. Well, I should say very deeply, because there are entire books written on the subject. But I think I do a good job of covering it in my book.
What about testing floats and extended numbers? Any tips on that?
I believe DUnit and DUnitX both have, a check float or check float value, and then you use a what's the math term? A buffer, not a buffer, the error margin of error somehow. I can't think of the word. Unfortunately, I'm not a math major. What's the word? Where delta. You can tell it I want to have an error margin of error of 0.001. I think it'll test numbers that way. Testing tolerance, yeah, thank you, Keith. Epsilon, that's another word that's used, yeah. And I think they have an assert call that tests for equality using an epsilon. I could be wrong about that, but I believe that's the case.
And Nick, your people can go to your link, or they just search Code Central. It was CodeRidge 6, Delphi dependency injection, and the Spring framework.
There we go. Thank you.
Trying to find the question so I could put in a link. I guess I could just choose anything at random.
It says code coverage does not cover extreme cases, etc. So for every code path, we must use at least 3 tests. Is this correct?
Well, code coverage will tell you will tell you which lines of code have been executed when you run your tests, and if there are lines of code that are not executed when you run your tests, you'll know that. Granted, it won't tell you if you've covered every possible execution path, but certainly a code coverage tool will at least tell you that you didn't test a specific line of code. So there is advantages of that. I agree that no code coverage tool can possibly tell you if you've executed every execution path. That's impossible.
So let's say you have 500,000 lines of code, no unit tests. Where do you start?
Well, I talked about that a little bit earlier. You look for places where you can write an interface, where you can find a seam in the code and peel off little chunks. You just keep doing that and doing that and doing that until your code is decoupled. It could take years. I mean, I sympathize because I'm in that exact situation with my project at my current position. So
I've worked places, something I don't think you mentioned it, but I've worked at a few places that have put unit tests in like another department. So the developers write the code, and then they have some interns that write unit tests or something somewhere else. And I found that never works.
No, it is the responsibility of the author of code to write unit tests for.
And you mentioned always making sure that you don't get too far off all your tests passing, and I found that it's like having that red light on your dashboard.
Oh yeah.
Once you start getting a couple of those, then you're like, which one is the right one? And
you should run your tests every minute. And if a test fails, you fix it immediately. A broken and a failing test should break your build. Failing unit test should break the build.
Okay, I think we're about out of time. I got most of them answered here. There's a lot of comments here, but I think we got questions answered. Oh wait, anything to improve in the way you use RAD Studio to encourage unit testing, easier testing, i.e., get away from less raditis?
Yeah, don't start with the form. Have the form be the last thing you write. Write your model, write your view, your middle tier, and then have the forms be just a very thin layer over all your business logic. Watch the model view model presentation by Malcolm Groves from Code Rage last time, I think, or 2 times ago, and start writing your code like that, and you will find that your forms are very, very thin and contain very little code.
It says you mentioned that logic, if clauses, should not be incorporated into tests. Then how to test logic, if cases, etc.?
You write one test for one side of the if, where the if is true, and then you write a test for the other side of the if, where if is false, where the clause is false. You should never put. I can't think of a single case where you should put an if clause in your tests. Your tests should be arrange, act, assert. That's it. Arrange the code so that you can test it, act on the code, and then assert. If you're putting an if statement in your code, then they're doing it wrong.
Oh.
Write two tests, I guess, is the answer to that. Write
Yeah.
one for one side and write for another one for the other.
So Jim had some code here. It says check equals and then parentheses 4 comma add 2 comma 2. I guess the way of consolidating all it down to one line. I don't know if you see that there or not, but I would.
Yeah, I saw that. I guess I would argue that that's hard to maintain and hard to read. So, and his point, which I take, was that it's easier to write, which is true, but making code easy to write and hard to read is not a goal we should aspire to. That'd be my response.
I know that I found the way you show it, showing expected and actual, makes it easier in my mind when I'm trying to line up with the call, because sometimes I get those reversed, and then the error you get back doesn't make sense. So,
right. You should always pass the expected one first, and then the actual second, because that's how the error message will read in the framework.
So there's a question here: how to apply this to legacy systems based on store procedures and triggers?
Well, this will only test Delphi code, so it won't test any SQL code. If you've got components based on inside of, you've got components that are wrapping up those store procedures and whatnot, then you can do integration testing to test those. But unless you've designed your code specifically to use, say, an iRepository pattern, you are not going to be able to very easily test your data-driven code. How's that for an answer?
I think that's good. So Jean points out that you can use the model view model to test part of the user interaction by the. Go ahead.
That is simply the way to write your applications from day one now. Use model view model. I recommend Malcolm Grove's presentation from Code Rage on model view model. It is the way to write GUI applications. If you use model view model, you'll end up with a very thin set of code inside of your event handlers, and all of the muscle and meat of your code will be in the view model and the model, which are eminently testable by design. So basically, you don't want to put any logic and business code in your event handlers at all.
So here's a question: what do you prefer after finishing unit tests? ... How can we disable all of these tests?
Well, you don't ever disable them. You always have them and run them. But you're not putting the testing code inside of your project or your application. It's a completely separate project in and of itself. So the tests are run in one executable, and the project itself is running in another executable. And those two executables share the common code between the two of them, but you don't ever want to turn unit tests off. You want to be running them forever. Once you write your unit tests, you want to run them constantly while you're developing to make sure that your changes and fixes and whatnot don't break anything. And then I would strongly recommend you run your unit tests as part of your continuous integration build as well.
So a real-world example is determining how many pairwise combinations are necessary to test a system, where the total possible tests are in billions, but it will only take a couple hundred pairwise combinations to fully test the system.
Yeah, there's a lot of statistical analysis on this. I mean, one of the things you can't do most of the time, I said if you can, test every single permutation, but if you're doing integer math or something involving integers, that's impossible. I mean, that's 2 to the 64 different possibilities times whatever permutations you could have. But it does make sense to test things down the middle and then the edges and around boundaries and things like that. And there are statistical analyses you can do as to where and what you should test if you really are into it.
Same question for DelphiMocks. Is tmock with the brackets looks extremely interesting? Is there some tutorial you can recommend?
Hello,
I've got
I'm
a
Malcolm
blog
Grimes,
post.
and in this session,
Whoops, there was the Model View
Sorry.
session.
That was me. Sorry about that. I was going to post the link, but it was auto start in YouTube. Sorry.
There's I wrote a blog post about the basics of it. My book covers the mocking framework pretty extensively, and there are demo samples in the project itself. So I'd recommend looking at those.
Are there unit tests for the DelphiMocks framework?
I believe it is unit tested, yes.
Are there unit tests for the DelphiX framework or DUnitX?
Yes, there are. It eats its own dog food.
So there's a question about C++ Builder. So we do have CUnit that ships with C++ Builder, and then David, I was going to look into whether the mocks and DUnitX would work with C++ Builder.
There's a couple of questions here about testing private units, and I said you can't test private units, but you shouldn't want to. If you feel the need to test them, then they should be public. And that elicited a response, which I understand. A private method should be run somewhere by public methods, and so you should test the public methods that utilize the private methods. If you really want to, you can do you can put a test in the same unit as the class that you want to test your private methods, but generally speaking, your private methods should be tested via the public methods that utilize them.
Would love to see more advanced version of this webinar, for example, using client dataset to mock data and more mock coverage.
Oh, that sounds great, yeah.
Or do you know of any good resources online that cover that sort of information?
There's tons of it for Java or .NET. As far as specifically for Delphi, no. I don't know any. There's not too much. I mean, as I said, I've got my book. I've written some blog posts on it. I think Vince Perret has done a couple of blog posts on mocking in DUnitX and whatnot. But don't be afraid of using, reading up on it from the .NET perspective or the Java perspective. The language is not that big a deal. The principles are all still the same, and Delphi can do all the things that those frameworks can do as well.
So here's a question. It says, how mature is DUnitX? It feels a little unfinished. I was browsing T command line, looks unfinished. Is there a roadmap for DUnitX, or should commercial environments stick to DUnit for the time being until DUnitX becomes more mature?
DUnitX is still a little unpolished, but it is completely usable. Most of the unpolishedness is in the runners. There's no GUI runner, for instance, that shows you the green line that slides across. But the runners for the console and for NUnit output, which would work with continuous integration server like Jenkins, are completely production ready. I think getting a GUI runner would make DUnitX look a lot more polished, but for right now you can use it. That's not to say that DUnit itself is not perfectly serviceable and usable. You can do everything you need to do in DUnit if you'd like to, so it's totally up to you which one you want to use.
So there's a question here about code coverage tools.
Yeah, I put a link into the chat there for the code coverage, which is right there. I put it in. Oh, you did it too. And also, David, I mentioned in the first webinar that AQTime does code coverage as well. So if you're looking for
That's right.
AQTime, that's a commercial solution.
Is DUnit only 32-bit XE5?
No, DUnit will work on 64-bit, and it should work from Delphi. What did we say? XE2 and up. No, DUnit will work back to 2010. It's Mocks that'll work from 2002, from XE2 and up.
Okay. When will your book be publicly available?
The electronic version is licensed by Embarcadero and available only to XE5 users. I believe that runs through the end of this quarter. Within a week or so, I should have the printed version available for purchase on CreateSpace.
Will that also make it on Amazon, or is it just going to be on CreateSpace.com?
I think it'll make it on Amazon, but I make more money when people buy it on CreateSpace, so I'm not going to tell anybody about Amazon.
Oh, okay. So don't go to Amazon.
I'll be pumping the CreateSpace link, which is basically an Amazon link because CreateSpace is an Amazon company.
So here's a question here about SGBD.
SGBD.
Does that mean anything to you? It doesn't mean anything to me.
SGBD doesn't mean anything to me at all, I'm afraid.
Database. It's a database. Procedures and triggers. Oh, that was okay. So yeah, you said that DUnitX doesn't cover database procedures and triggers, but you would need to use a mock in order to isolate your code from the database, right?
That's the general approach, is that you should write your code in such a way that your database layer is mockable. Now, of course, most people don't have that written that way right now, so writing unit tests for your database-based code is going to be challenging until you can separate out and isolate out the database access layer.
What about setting up, tear down a test database to have actual data access as your mocking layer?
You can do that. Then you're integration testing. You're not doing unit testing anymore, and you're not testing your code in isolation, but certainly that's a very valuable thing to do.
So someone pointed out the AQ time is for code profiling, but the Pro version does
code coverage. Yeah. Now, this question here, I used the phrase friendly class, and maybe I didn't clarify that enough. A friendly class is a class that basically runs without any ramifications or external dependencies. Probably a very common friendly class would be string list, right? You might have a dependency on string list, but it's a friendly class and it doesn't do anything that requires anything external, so you can just continue to use it as a standard dependency without worrying about external entities.
So a friendly class is one that... Okay, I think I understand.
Sorry.
Well, so what quickly is code coverage?
Code coverage is a method of measuring how much of your code is actually executed. So a common way to use code coverage with unit testing would be to run your unit test executable under the code coverage tool, and then have the code coverage tool tell you how much of your code was actually executed when the tests ran. And then it'll tell you, you ran your tests, but these lines here and these lines of code were never executed. And then you can write code, you can write tests to ensure that those lines of code are executed, with the goal of making sure 100% of your lines of code are tested. Now, that is not to say that every execution path is covered. It just means that every line of code was at least run once. And those are nice. That's a nice test for making sure that you at least one time run by every line of code on in your application, or in your code base, in your framework, whatever.
What HTML writer are you using?
What HTML writer am I using?
Yes.
I don't know what that means. I wrote HTML writer is an open source project that I wrote, and I used DUnit in that for all the tests in that. But that was before DUnitX came out.
How can you switch from traditional way of programming to the unit test oriented one more efficiently? What are the practical advices? What is the practical advice you would give a traditional programmer eager to switch?
Well, I would say from this point forward, use test-driven development to write your code. In other words, write your code in such a way that it's very, very easy to unit test. I would examine and take a look at Malcolm's MVVM model so that you write testable code on the back end and very thin layers of GUI over the top of that testable code on the front end, on the user interface. The main benefit really of unit testing is that by unit testing your code and writing testable code, you're writing good code, well-designed code. As I said I use the phrase "happy coincidence" in the video. It's a happy coincidence that testable code is also well-designed code, i.e., loosely coupled code. So basically, when you're writing your code, think to yourself, how am I going to test this? And if you say, oh, that's really hard to unit test, then you're doing it wrong. Write code that's easy to unit test, and you'll end up writing decoupled, well-designed code.
Okay. Nice talk on database testing. You could always have a dedicated database to test. So this goes back to, again, it would be integration testing if you are testing against an actual database.
Yeah, that's a perfectly legitimate thing to do. It's just not unit testing, and that's fine. It's just you want to do unit testing first before you start in on integration testing. And you want to test your code in isolation. You don't want You want to be able to test your code without depending on the database to make sure that your code works before you start making sure it works with the database.
Do you use the open source code coverage tool?
I do.
In your experience, can you say that you're more productive? Could be a dumb question, but test-driven development will not double the code time.
It might double the coding time, but it cuts overall time in half then, or even more. I made a couple points couple of points I'll highlight from the video. One is that you test your code when you write it, or at least I do. Before I started doing unit testing, I mean, you run it and make sure it works, and that time that you spend building the test or whatever it is, or however it is you're running it to make sure it works, is time you could spend writing unit tests. Overall, big picture, maintenance-wise, long-term, writing unit tests saves huge amounts of time because you write tests for code that you want to work, and if you write tests for it, you know it works, and then you know it's not buggy, and you can continue to prove and know that your code works, and that's really good. That writing code that you don't know for sure works properly is not a way to save time in the long run, maintenance-wise.
Any statistics on maintenance time reduction from test-driven development?
There probably are, but I don't know them off the top of my head.
I know that the book Code Complete, which is been around quite a while, but it's still reliable, talks about fixing bugs earlier versus later. And the later you fix a bug, the more time it takes to fix it. And that's definitely something, a gain you get from test-driven development.
Absolutely. If you're running your unit test with your code coverage tool, with your continuous integration tool, then a failed test will let you know right away that a bug has arisen. And you should consider a broken test or a failed test a broken build. You should consider that if you write a failed test, if you have a failing test, you should fix that immediately. And the farther away
like you said, yeah, the sooner you fix a bug from the point that the bug is introduced, the less costly and time-consuming it is.
Does easy to unit test mean interfaces should always be used? Seems easier to mock an interface than a class.
It's much easier to mock an interface than a class. I recommend that you code against interfaces and not against concrete classes. Code against interfaces, not implementations, is a base, axiom of good coding technique, and it's one of the reasons that you should write against interfaces and not implementations is that interfaces are easier to test, or the classes end up being easier. The classes that implement your interfaces end up being easier to test. Relying on interfaces is always a good thing.
Can you speak more about testing legacy code? All procedural, lots of spaghetti. Where to start? Next steps.
My recommendation would be to get a hold of a book called Working with Legacy Code by Michael Feathers. Read that book and follow its precepts. It is a book exactly about that very thing. It's written for Java developers, but again, don't be afraid of that. That there's no reason to be. There's no reason to be afraid of the fact that the book is written for Java developers or whatnot. It is an excellent resource that discusses exactly the steps one could take. And one of the basic things you do is just slowly but surely find seams in your code for introducing an interface, for wrapping up procedures into a single class that can then be tested, and just gradually, slowly but surely work your way through your code base until it has been decoupled. It's sort of like if you have a big tangled ball of yarn, the only one way to untangle it is to very patiently, one by one, find the end and work your way through it. And sadly, that's the way it's got to be, but oh well.
I know earlier you mentioned the idea that you, as you write new code, make sure it's under test and then look for a seam, an easy place to start, and just start going for it.
Right, yeah.
It's like the old adage of how you eat an elephant, right?
Exactly, one bite at a time.
Does DUnit memory leak checking work in your experience?
I haven't really used it to do that very much, so I can't say whether it works or not, but the fact that very few people use it probably is indicative. I don't know. I confess I don't know what to say.
I know the memory manager's leak detection works pretty good.
Yes. Certainly the best way to test leak detection is to use a fastmm. Yeah.
Fastmm, yep. Do you use unit tests for performance testing?
No. The unit testing won't speak to performance at all. Yeah, leak testing should be done with fastmm. That finds memory leaks faster than anything I know.
Yeah, I also noted that AQTime does, well, on Windows will do
leak checking too.
Yeah.
So here's another comment about putting unit tests in the same unit as the tested class to test private methods, if there's more comments about that.
I'm opposed to that notion. I'm definitely opposed to putting unit tests in the unit itself, because then those unit tests are present and compiled into your production code. You don't want to mix testing code and production code just for simple maintenance processes. And again, if you've got a private method, the way to test that is via the public method that utilizes it. And make sure that the public method works correctly, then you know that the private method works correctly. That's my position. If you want to disagree, I'm perfectly happy to accept that. Yeah.
So Ed says apparently the memory leak checking in DUnit works very effectively. You can register expected memory leaks for things like Indy or choose not to use Indy.
Great.
So
That's
apparently it does
cool.
work.
That's good.
And FastMM is like integrated with DUnit.
Very good.
Okay, I think that we're. Oh, there's another one. Wouldn't leak testing in your tests make it pretty easy to find out where the leak was caused instead of just knowing where there's a leak?
Yeah, sounds like a good technique. I didn't discuss that, and I haven't done that, I confess, but I certainly will look into that.
So Scott wants to know where to find the DelphiMocks library.
I'll drop the link right into the chat room here, but if you type Delphi space mocks into Google, it should be the first link that you get. It is on GitHub. Hang on, I'll put the link in the chat here just a sec.
Vsoft Technologies.
Yeah, that's Vince Perrett, who is on this webinar. Thank you, Vince, for all your contributions.
So regarding the one check per test, the counter view is that if the test checks all inputs for the method under test, then really it's saying that method is working. Using correct fail message just tells you what went wrong. Usually if the method fails, it affects multiple checks. When you fix it, they all pass.
And if that's the way you want to do it, that's, your mileage may vary. I'm a one assert per test guy. But if you feel you need to organize your tests differently, I'm not going to sit there and point the finger at you. I'm just glad you're writing tests, and I'm sure you're glad you're writing tests too.
That's one thing, is that there's certainly lots of different ways to do unit tests. It's important thing is that you are doing unit tests.
Yeah. Some tests written with multiple checks per assert are better than no tests written with no checks per assert.
Yes. Are there any docs on the APIs for DUnitX?
Not other than any documentation that might be in the code itself in the comments. I don't believe there's any docs. It's a very simple. It's pretty simple, and the sample apps that come with it demonstrate almost everything that it can do. So my talk covered almost all of it. Really, there's a lot of what am I trying to say? There's a lot of code out there already using it in some of the open source projects. There's unit tests for DUnitX in DUnitX that use it, so you can see how it's used, and there's not a lot more to it than what you've seen already.
And there are examples. If they go to the GitHub, you'll see examples for every release 2010 through exe5.
And Vincent just pointed out that Robert Love is working on docs using Documentation Insight, the very powerful IDE tool, which is good. I always feel like I should be contributing in that area as well.
Well, you did write a great book on the subject.
Well, thank you.
Which is useful as well. Okay. Do you know who's maintaining DUnit2 these days?
I do not. I don't know much about DUnit2, I confess. I should look into that, but Jared Hollingworth said he is. So, okay, that's an easy question to answer.
Thanks for that, Jared. Okay.
Sean says he's written a complete GUI front end for DUnitX and a wizard for it. That's very nice.
Oh.
Do a pull request and hopefully include it. That'd be great.
So that should be coming soon. What areas that are traditionally difficult to test are GUI and database apps. True.
What do we have to say about that? I would agree that you're right. GUI should not be unit tested, but a purist would say that you should definitely test all of your database code as well, and that you should write it in such a way that it is testable. And one of the ways to write it that it's testable is by using the iRepository and the unit of work patterns. If you want to look those up, they'll show you some. They'll give you examples of how you can isolate your database access code in such a way that it's testable. And excuse me, I recommend you do that.
I remember, and when reading your book, you had a lot of references to other books that were very in depth on the subject matter, but not necessarily about Delphi. And
Sure, yeah. There's tons of information out there on how to isolate databases, how to write a repository pattern, how to write a unit of work pattern. It's, a lot of it's in Java or in C#, but don't let that deter you. The principles all remain the same, and the code is easily translated and usable, and the principles are all the same.
So Colin says,
don't be afraid.
Yes, exactly. It's a lot. Well, in a lot of your book is the theory behind it, and that's exactly what you're going to get in the other book as well.
Yeah.
Sounds like you need testable code inversion of code control? Question mark. I guess it's saying inversion of control makes code testable. Is that what you're saying?
Yeah, basically if you use good inversion of control or dependency injection principles throughout all of your code, that will create testable code, and testable code is well-designed code, as I said in the talk. As I mentioned, it's a happy coincidence that testable code, i.e. code that can be easily unit tested, is also code that's loosely coupled and thus well-designed. So it's a win-win all the way around.
Can you quickly cover the attribute test case in DUnitX?
Yeah, that's an attribute that allows you to feed data into the test. So if you have a set of parameters that need to go into the test, you can use the test case attribute to set those parameters, and you can have multiple test case attributes on a given test, and they will those test case attributes will be run as test inputs. So it allows you to use one test with multiple data inputs. So for instance, in the demo I did, it's obviously very simple, but for the addition, you could put you could write one test that would, and then enable you to pass in multiple integers. So you could say 2 plus 2, 2 plus -2, -2 plus 2, -2 plus -2, all with one test, each of those inputs using the test case attribute.
So it sounds like a compromise between the one check per test and testing multiple similar cases within the same test?
Yes, that would be a good way to put it. Yeah, exactly.
So there you can both be happy that way.
There you go.
I personally think using a mnemonic with identical letters is a terrible idea. Well, AAA. If it fails to remind you what the item names are or what the order they should come in.
Okay, that's just a convention in the unit testing world. If it's tough for you, then I can understand that.
Will the multiple test case attributes be treated as separate tests for a test method?
Yes. If the fifth one is bad and fails, then the unit testing framework will report out with that specific data as the failed test.
And do you pass in the data as well as a message for each data point, or is it one message for all data points?
One message for all data points, but it'll pass you back the the exact inputs.
So instead of having
you can report out too. You can say, you can do a message on your test saying, for X and Y, I got Z, and the H, X, and Y can be replaced with using a format statement or whatever.
Okay. Okay. Patrick says, excuse his complaint about AAA. It was just he said it was an excellent demo otherwise.
No problem. I totally understand. I have to stop and think about what it means actually myself. So.
Yeah. Have you ever applied unit testing large scale to a legacy code base, e.g. traditional Delphi RAD app, or as you called it earlier, RAD-itis?
RAD-itis.
That wasn't designed with unit testing in mind. Any tips?
Yes, I have. That's what I do every day. Currently, I'm maintaining a Delphi application that was most assuredly not written with unit testing in mind. And the tip I give is get a hold of a copy of Working with Legacy Code by Michael C. Feathers. It is an outstanding book that tells you exactly how to go about doing that exact thing, i.e. the notion of teasing out interfaces and teasing out portions of code that you can start unit testing. It's an outstanding book, and I highly recommend it. And I liken it. I think I said at the last session that it's sort of like untangling a big ball of yarn that's all tangled up. You just have to work at it, work at it, work at it a little bit at a time until you get all the string loose and straight and then organized well. And that's basically how you have to do it with a a spaghetti code legacy app. And there, David put the link to the book right there in the
Oh, excellent.
in the chat room. It's a great book.
Peter says he once wrote some unit tests for a piece of legacy code that was 18 years old and well trusted by the organization. I'm guessing his unit tests were used as the definitive statement about how things should be done.
Yeah, that's a great. I mean, that's one of the main things I mentioned too, is that unit tests can document what the code is supposed to do. And if you have a nice suite of unit tests that cover everything that your code is supposed to do, that could be something that someone could look at and see how to use the code. It's a really nice feature of unit testing, is that it documents it.
So Vincent chimed in and said that DUnitX test cases create individual tests with the parameters as part of the name. So you see which inputs cause the test to fail.
There you go. Yeah, exactly. Thanks, Vin. Thank you, Vincent.
Okay, I think we're about caught up here. Something that came up earlier that wasn't mentioned now was the dealing with private and protected members of classes and how to test those.
Yeah, my answer to that is that you should test private and protected methods through the public methods that utilize them. And if there is no public method that utilizes that private method, then you don't need it, really. You can't test private methods. I'll just use private for private and protected so I don't just say it all the time. You can't test private methods, really, because you don't have access to the private methods outside of the unit. You shouldn't be putting tests in the unit. And so you really can't test private methods. But as I said, the way to test private units is through the public methods or properties, that access them. So find the place where the public method is utilizing the private method and test that public method.
So if you have a private setter, you just use the property, set it through the property, and then read the property back out?
Right, especially if you've got logic or other side effects inside the setter and the getter. So.
Okay. Excellent.
And I just put reminder links in again for the ADUG Autumn Symposium, March 20th. That's a Thursday in Melbourne, and Friday, March 21st in Brisbane. And you'll find all the information, including past symposium going back to 2005, actually, 1999. Wow.
Yeah, a ways back.
I was at a few of them. It has the schedule. In Melbourne, it's at La Trobe University. In Brisbane, it's at the Mercure Hotel. Nick will be there. Damien Bootsma from Embarcadero will be there as well. So just a reminder, if you're down under somewhere, go to the ADUG Day in Melbourne and or Brisbane. It's really wonderful.
Here's a question about unit tests to test the performance of a unit.
Unit tests don't really test performance. You'd need to use a profiler like AQTime or some other third party to do performance testing. Unit tests test correctness. They don't test performance.
says when you finish the unit testing you're doing in your day job currently, will it still be a Delphi RAD application in your opinion?
Yes and no. Depends on your view of what a Delphi quote RAD application is. If you're looking for to write testable code, you don't want to be doing pure RAD. That is, writing code in on-click event handlers. My recommendation is that if you haven't already, take a look at Malcolm Grove's MVVM talk and start writing your code in MVVM fashion. I wrote a new utility at work over the last month using MVVM. It's a pretty simple utility, and some might argue that MVVM was an over-controlling, over-engineering. But it came out very well, and it certainly helped me understand more clearly the principles of MVVM. And the MVVM is a model view model. So you have a model, that's testable. You have a view model, that's testable. And you have a view, which is the GUI. And the GUI actually ends up being so thin a layer over the view and the view model, over the model and the view model that you don't really feel the need to test the GUI at all.
Excellent. Yeah. Yeah, you test the parts that can fail, and you don't need to worry about the rest.
Yep. Yeah.
Okay. Well, I think
there's some more coming in here.
Is there? Okay. Oh, there it is. I lost my window. Are there similar tools for testing C++ in RAD Studio XE5?
I believe there's CUnit that allows you to write CUnit unit tests.
Can you test for memory leaks in DUnitX?
I don't think you can, but I think that's in works. Maybe Vincent can answer that better than I can. Somebody, let's see, Colin Johnson pointed out Roy Osherov's book, The Art of Unit Testing, which again I highly recommend. It's all C++, it's all C# examples as he notes, but still a very, very useful book. Doesn't matter what language it's written in.
If the whole built-in unit in Delphi has been tested, I must have missed part of this question. Oh, is the whole built-in unit in Delphi has been tested using this method? I guess it's asking if the RTL is tested using this method.
When I was at Embarcadero, they were in the process of trying to get all code coverage over the entire RTL with unit tests, and I presume that has continued to be the case. I know Alan's a strong supporter of it, so I believe much of it is. There's thousands and thousands and thousands of tests that are unit tests that are run every build. So yeah.
Do you have any recommendations for system testing?
I guess I'd have to ask what the definition of system testing is.
So Jared Hollingsworth said, for C++ builder, use DUnit.
Okay. I'm not a C++ guy at all.
Yeah, that was my fault from earlier. I posted a link to the doc wiki.
So for what's the difference between DUnitX and DUnit? Why would you choose DUnitX over DUnit?
Well, simplicity of creating test cases is probably the number one reason. I guess it would be a matter of personal preference. DUnitX is being actively built up, and the current DUnit project is not, although Jared apparently is working on DUnit 2 quite well. It's a personal preference. I prefer the attribute-based. I think it's cleaner and easier to see and easier to read. I prefer the attribute-based system, but both systems work quite well, and both will get the job done for you. I'd rather you spend your time writing unit tests than worrying about which framework you're going to use.
Okay. It's difficult to write tests for code that is dependent on the current time. For example, testing a logging framework that includes a timestamp in the log entry. You need to be able to control or inject the time.
Yeah, I kind of get what you're saying there. Yeah, that is a challenging thing to do. I wrote one of the side projects I had when I was Delphi R&D manager was I wrote a bunch of unit tests for the date utils unit, and that gets to be challenging to test dates. I guess I would say write the tests with as much fixed sample data as possible. Beyond that, I don't have much to add. Sorry.
Any recommendations with folder file organization for a test project? A test unit for each class, a unit for method under test? Question mark.
I just generally have a unit. I have a directory with my code in it, and then underneath that I put tests, and then I have the project and the test units in that unit. I keep saying unit in that directory. So that the tests are self-contained in a single directory. That's the way I do it. Of course, it's that's just my way of doing it. Your mileage may vary. You can do it however you like, but that's how I do it, and I'd recommend that. It's neat, it's clean, it keeps your tests in a single directory.
What do you think about using randomization in unit tests?
Purists would tell you should never do that. That all your tests should be deterministic and run the same every single time. But sometimes it's nice to be able to do that. If you want to run thousands of tests, you can randomly pick numbers. So I generally would shy away from it.
Does DUnit work for Delphi 2010 and later?
Yes, DUnit actually would probably work with Delphi 2, my guess. But I think it was written around Delphi 5 or 4 time frame. So Delphi, DUnit goes way back. DUnitX only works for 2010 and up.
DUnit uses interfaces for Delphi 4.
Yeah, that sounds probably right.
Yeah, I was going to say Delphi 4 had a lot of big language changes, so that seems like probably a good cutoff point.
Yeah.
I was going to say not that anybody's using earlier than Delphi 4, but probably there are people using earlier than Delphi 4.
If you're using Delphi 4, it's time to upgrade.
It is time to upgrade.
Yeah.
Interface is one of my favorite additions to the Delphi language all time.
Maybe the greatest addition of all time, in my opinion.
Personal opinion. Personal opinion.
Yep. Grossly underutilized language feature, in my opinion, but that's just me.
Well, we're using them a lot in FireMonkey. So.
Yeah. Code against interfaces, not against implementations. That's my motto. If there's one thing I could teach a developer, it would be that.
Jim, I'm not sure if you saw the Lackland. I'm not sure, Nick, it was when you finish the unit testing you're doing in your day job currently, will it still be a Delphi RAD application in your opinion?
Oh, yeah, I didn't type the answer on that one.
Oh, sorry.
Yeah, we talked a little bit about that. It's an interesting question, and my answer, again, was it depends on what you mean by a Delphi RAD application. If on-click programming is your thing, then knock yourself out, but you're not going to be able to unit test that. So I would much rather write an MVVM application that's highly unit testable and thus highly maintainable.
So Peter says that empty except blocks are probably the most overused language feature.
That's just not right. Yeah.
Read Nick's book. You've got all sorts of good advice for things that people shouldn't do.
I have a chapter on exceptions in the book.
Yeah.
Is it possible to make a unit for application connecting with other interface using, let's say, Bluetooth or COM port, USB connection, etc.?
Yeah, that would be the perfect example of writing tests with mocks. I mean, you need to write at that point a mock for the Bluetooth interface and have that answer, have the interface respond deterministically to your tests. If that's that's a testing in isolation. If your tests depend on some type of Bluetooth device, then you're going to have a challenging time running those tests with your continuous integration tool.
So Robert shared a link. He says this is the Art of Unit Testing second edition. I just posted that through there.
The second edition has just come out in the last month or so, I think, if I'm not mistaken, or very recently anyway. I definitely would recommend that book.
Uses C#, but still good reference.
Yeah, oh yeah, doesn't matter.
Okay, I think we're caught up.
Okay.
Wow, all right. Well, thank you, Nick. This was fabulous, and I learned a lot again.
Good. Thank you very much. I was very pleased to do it. It was fun.
Yep, you made it to all three times. For you,
I didn't sleep through anything, yeah.
Yeah. And Jared's saying, excellent talk, Nick. Lots of kudos coming in all around.
Good, thank you.
And for everybody, we'll have the, since I'm on vacation next week, I'll deliver to marketing, the field marketing, product marketing, the replay with the Q&A from all three sessions stuck on it. They're building a page that has a white paper from Nick as well, I believe, Nick?
Yes, there's a white paper that is an adapted portion of my book, yes.
Yep. And then for all of you, if you need things like slides or samples, Nick has all that stuff listed as far as code and other things. And all of his account information is still there, including social security number. So you can figure that out how to reach the slide that's up there. And again, Alistair Christie is saying thanks for the talk. Hope to see you at ADUG if you can swim from New Zealand over to.
I'd love to meet you, Alistair. That'd be great.
Yeah. And everybody have a great time down under, and we'll see you again online real soon, or in a city somewhere on the planet Earth.
Yes.
Thanks, Nick. Thanks, Jim.
You're very welcome. Thank you. Bye-bye.